Hi everyone. In this video, we are going to discuss about how to find the equation of the bisector of an angle that contains a given point. And this angle is an angle between two intersecting straight lines which are not perpendicular to each other. In the previous video, we have seen how to find the equation of bisectors of all the angles between two straight lines. And here we are going to determine which one of them would be the bisector of the angle that contains a given point. Let's suppose we have a straight line like this. Let's call it straight line A, whose equation has been given as A sub 1 times x plus B sub 1 times y plus C sub 1 is equal to 0. And as we know, each straight line divides the plane into two distinct regions. One region would be the positive region for that straight line and another region would be the negative region for the straight line. So let's assume that the two regions for this straight line are like this. Let's suppose we have the right hand side of this straight line as the positive region and the left hand side as the negative region, and then we are going to take another straight line which would be an intersecting straight line, and of course they will not be perpendicular, so we are talking about two intersecting straight lines which are not perpendicular. So let's suppose we have another straight line like this. Let's call it straight line B, whose equation has been given as A sub 2 times x plus B sub 2 times y plus C sub 2 equals 0. And this straight line also divides the plane into two distinct regions. One side would be its positive region, another side would be its negative region. And let's assume that the right hand side of straight line B is the positive region and the left hand side region is the negative region, right? So then the four regions here for these two intersecting straight lines, there are four regions, and those four regions going to look like this. So here I have denoted how each of these four regions look like with respect to each of the straight lines. For example, the region right here on the right hand side, this region is a positive region for straight line A as well as a positive region for straight line B, as per our assumption of course. And similarly the region down below, that region is positive for straight line A and negative for straight line B. And then the region on the left hand side, it is negative for both A and B, and the region at the top, that is negative for straight line A and positive for straight line B. Now we already know the two equations of the two angle bisectors are kind of like this. One goes with a positive sign and the other one goes with a negative sign on the right hand side of course. Now as we know, each of these actually represents a distance, and that distance is the distance of the moving point P that maintains equal distance from two intersecting straight lines. This is from our previous discussion. So each of these expressions right here, they represent a distance. Since each of them represent a distance, we take the positive sign when the expression in the numerator is of the same sign for both of the straight lines, and we take the negative sign when the expression in the numerator is of opposite sign, because ultimately we have to express both sides as a positive quantity, right? Because we are equating the distance from two straight lines of the moving point P, and that is how we derived the equations. And we use the positive and negative sign because when the two expressions in the numerator on left hand side and right hand side, when they have the same sign, then we can go with a positive sign because ultimately they will become the distance of same sign. Now when they have opposite sign, then we have to go with a negative sign because ultimately we have to represent both the quantities as a positive quantity. For example, let's suppose that our given point Q is like that. So let's suppose the given point is Q. It's in any of these four distinct regions, and let's assume that its coordinates are h, k. And if we use the coordinates of Q in each of these expressions, right? First I'm going to use it in the expression of straight line A. So it will be A sub 1 times h plus B sub 1 times k plus C sub 1. Now if this is a positive quantity, and let's also use it for the straight line 2, so it would be A sub 2 times h plus B sub 2 times k plus C sub 2. If that is also a positive quantity, then we can say that the equation of the bisector can be written with a positive sign. So let me denote that right here. So if both of them are positive, then guess what? The left hand side quantity and the right hand side quantity, they both will be positive. So we can go with a positive sign. So in that case, we are going to go with a positive sign. Now let's take another combination. Say suppose we are now talking about the bottom region. In the bottom region, we have A positive and B negative. So for the first straight line, the expression will be like this: A sub 1 times h plus b sub 1 times k plus c sub 1. If this expression is positive and the other one, which is a sub 2 times h plus b sub 2 times k plus c sub 2, if this expression is negative, then guess what? For our equation of the angle bisector, we have one value positive and another value negative. In that case, we have to go with a negative sign, because then one side will be positive, another side will be negative, and if I take a negative sign on the other side, then both sides will become positive then, right? Then we can balance, then we can equate them. So when they have the same sign, we go with a positive sign for the equation of the bisector, and when they have opposite sign, we go with a negative sign for the equation of the bisector, because that equation has been formed based on a very basic principle that the locus of the moving point P, which maintains equal distance from the two intersecting straight line, and we are talking about that locus as a bisector, so that distance of that moving point P being equal from both straight lines, right? Now that distance is nothing but a positive quantity. It's a simple positive quantity. But here, because of the four regions having different combination of signs with respect to each of the straight lines, we have to clearly understand that whatever is the sign of each of these expressions, we have to carefully create our equation of the bisector with the correct sign. Now let's also take the left hand side region, for example. Left hand side region has both negative. So if I would write it here, for the left hand side, it would be like this. For straight line A, it would be A sub 1 times H plus B sub 1 times K plus C sub 1. That would be less than 0. We are talking about the left hand side region. And similarly, A sub 2 times H plus B sub 2 times K plus C sub 2, that will also be less than 0. Now in this case, since both of them are negative quantity, we will still go with a positive sign. Now if you are thinking, hey, both of them are negative, why should we go with a positive? We should go with negative. No. When we created the equation of the angle bisector, our simple theory was like this. We have one distance on the left hand side of the equal sign and another distance on the right hand side of the equal sign. So suppose we have a distance of 5 units here. So first expression is giving us negative 5. Second expression is also giving us negative 5. Isn't it same as 5 equals 5? If I multiply both sides by a negative 1, when both quantities are negative, it's same as both quantities being positive. That is why we are going with the positive sign. But when one of them was positive and the other one was negative, so suppose right here in this example, so the first one was positive, let's assume it is positive 5, and then we have to equate that with a negative quantity. So forcefully what we did, we added an extra minus sign for the right hand side, and that is why when the two expressions gives us opposite signs, we go with an extra negative sign. When two expressions give us same sign, we simply go with a positive sign. I hope this point is clear. And similarly for the top region, which is actually negative for A and positive for B. So for the top region, then our expression should be like this: A sub 1 times H plus B sub 1 times K plus C sub 1. This is negative for A, and A sub 2 times H plus B sub 2 times K plus C sub 2. This is positive for straight line B. So then this situation is like this, and here we need to go with a negative sign. Now here again, why we need to go with a negative sign? Well, because of the same example. If we take the example like this, suppose in this case the first expression is giving us a distance of say negative 5 units, and the second expression is giving us a distance of positive 5 units, and somehow I have to equate them, and to be able to equate them I have to forcefully introduce a negative sign, and then guess what? Then we can equate them, because we can equate only equal quantities, right? We cannot equate a negative 5 with a positive 5. We can equate a negative 5 with a negative 5. And why are we trying to equate them? Well, just to create the equation of the angle bisector. In the previous video, when we created the equation of the angle bisector, we found the distance of the moving point P from each of the straight lines, and then we equated them, right? And that is how we created the equation of the angle bisector. So for us to be able to equate them, we have to be mindful of the sign of this quantity. If both sides are same sign, then when forming the equation we can go with a positive sign. When both sides are opposite sign, then we have to go with a negative sign on the right hand side. Then only we can equate them. I hope it made sense. So if we want to summarize this, we can say that if both of these expressions have same sign, like in these two examples, let me highlight them. So this is one example where both of them are of the same sign. Here is one, and here is the other one. Using the coordinates of the point Q, when both of the expressions give us a value of same sign, whether both of them positive or both of them negative, we go with the positive sign. That means when forming the equation of the bisector, we go with the positive sign. Let me highlight that too. And then when both of them have opposite sign, like these two scenarios, like here is one situation and here is another situation, when both of them are of opposite sign, then we have to go with a negative sign. So let me quickly summarize this. So here I have noted that when the expression a sub 1 times h plus b sub 1 times k plus c sub 1 and the expression a sub 2 times h plus b sub 2 times k plus c sub 2 having same sign, then the equation of the bisector would be with the positive sign on the right hand side, and that angle will contain the point Q whose coordinates are h comma k. So that will be the bisector of the angle that contains the point Q. And now when those two expressions have opposite signs, then we have to go with a negative sign for the equation, and that will be the equation of the bisector of the angle that contains the point Q. Now let's take an example and try to understand how to determine this. Let's suppose we have been given the equations of two straight lines like this, and we have been asked to find out the equation of the bisector of the angle that contains a point Q whose coordinates are, let's say, 10, 15 for example. So first we are going to quickly evaluate each of the expressions using the coordinates of Q. So from the first one, what do we get? Well, if we use the coordinates of Q from the first one, then we're going to get something like this. It would be, in place of x, I'm going to use positive 10. That's the x coordinate of the point Q. So positive 10, and then minus y would be 15, and then plus 2. And this quantity is actually 12 minus 15, that is negative 3. So essentially this is a negative quantity. And let's evaluate the expression for the second equation. There we have 2 times x, so that would be 2 times 10 plus y, which is 15, minus 6. And if we do the calculation here, it would be 20 plus 15, that's 35, minus 6, so that is 29. So this is a positive quantity. So looks like both the expressions are giving us a value with opposite sign when we use the coordinates of the point Q. So because they are of opposite sign, we have to use the second equation for the bisector of the angle that contains Q. Second equation means we have to use the negative sign on the right hand side. The second one that I have in the white box right here. So we are going to use the second one because here the two expressions when evaluated with the coordinates of the point Q giving us values of opposite sign. So we need to use the equation that has a negative sign. So the equation of the angle bisector is going to be like this. It would be the left hand side expression of each of these straight lines. So it would be x minus y plus 2 over square root of a sub 1 squared plus b sub 1 squared. That is, a sub 1 is actually positive 1, that's the coefficient of x, and b sub 1 is actually negative 1, that's the coefficient of y. And we are going to use the negative sign, and then the right hand side expression would be 2 times x plus y minus 6 over square root of a sub 2 squared. A sub 2 is positive 2 in this case, so that would be positive 2 squared, plus b sub 2, that is actually positive 1, that's the coefficient of y in the second equation. So b sub 2 is a positive 1, so positive 1 squared. And if we simplify this little bit, it's going to look like this. So from here we can say that x minus y plus 2 over, this is square root of 1 plus 1, 2. So this is square root of 2 is equal to negative of 2 times x plus y minus 6 over square root of 5. 2 squared is 4, 1 squared is 1, that's square root of 5. And from here if we cross multiply them, it's going to look like this. So we can say square root of 5 times x minus y plus 2 would be equal to negative square root of 2 times x plus y minus 6. And from here what we get? We get square root of 5 times x minus square root of 5 times y plus 2 times square root of 5, all on the left hand side. And then on the right hand side what do we have? We have negative 2 times square root of 2 times x, and then negative square root of 2 times y, and then positive 6 times square root of 2. And if we bring everything to the left hand side, then it's going to look like this. For the x terms, it would be positive square root of 5 and another positive 2 times square root of 2. So that would be square root of 5 plus 2 times square root of 2 times x. And then for the y terms, we have a positive square root of 2 and negative square root of 5. So we can write it like positive square root of 2 and negative square root of 5 times y And then for the constant terms, we have 2 times square root of 5 and minus 6 times square root of 2. All of that is equal to 0. And that is the equation of the bisector of the angle that contains the point Q. Though this equation looks a bit crazy, but if you think about it, this pretty much looks like an equation which is kind of like some constant times x plus some constant times y plus some other constant equals 0. So this is actually an equation of a straight line, and this is the equation of the angle bisector, the bisector of the angle that contains the point Q. I hope everything made sense. Thank you for watching. See you in the next video.